Hey guys, this is Dr. Bob with Summer Science in the Northern Neck. Today we're going to play detective, but not the normal kind of detective. We're going to be a chemistry detective. So a normal detective gets to go and ask people, what did you see? What happened? What time was it? Who was it? All the questions that that person might have to solve a mystery. But the last time I checked, molecules don't talk to us very well. You can ask the glass of water what it's made of, but it won't tell you. You have to figure it out. What we're going to do is we're going to use a technique known as chromatography. Now, that's a big fancy word that literally translates to color writing. Chroma is Greek for color, and graphy means to write. But like most compound words, it doesn't quite mean it's what it literally says. To a chemist, chromatography is the science of separating mixtures. And today we're going to look at a particular type of chromatography called paper chromatography. Now, this is a very fundamental means that chemists use to separate mixtures to see what the individual components are. And what happens is you put your sample on the paper, you'll need a solvent, something to develop it, and as the solvent moves up the paper, the material in the mixture should begin to separate. To do this, we're going to use water as our solvent because you have that handy at home. And what we're going to analyze is one of a couple of things. You can use water-soluble markers. Highlighters that you may have work really well. Food coloring will work, and you can use food colorings by itself, or you can make mixtures of food coloring. And sometimes the candy coatings on things like Skittles can be dissolved off and used as a source of material for chromatography. So what are we going to need to use this? It's called paper chromatography, but we're not talking about regular paper. I don't think notebook paper will work. What you need is either a coffee filter, a paper napkin, or a paper towel. Those will work. You'll need a little bit of Scotch tape, a pencil, a small juice glass, some water, and a scissors to cut the paper up. In the demo that follows this introduction, we'll go through all of that. You'll also see an unexplained toothpick in that demo. That can be used as an applicator. If you're not using a marker, use the toothpick and dip it into the liquid and use that to lay down the sample on your paper. Have fun with this. This is an investigative tool that chemists use in the real world. I've used it many times to separate mixtures, and it's a great introduction into how chemists become chemical detectives and analyze and figure out what's going on with mixtures they're presented with to separate. So have fun with this, guys. Give us some feedback on the Facebook page, and we'll come back soon with yet more summer science in the Northern Neck. Take care, everybody. Bye. Okay, we're back. I've gathered the tools that I need to do paper chromatography. The first thing is a napkin and a scissors to cut the napkin into small strips that you see here. Then I'll need something to do chromatography on, so I've chosen these watercolor markers, and a bit of tape and a pencil to hold things up, and I'll show you what I mean by that in a second. So what you're going to want to do is take one of the markers and just make a mark on the paper napkin that you've cut up and arrange it close to the bottom, but not actually right at the bottom, because you're going to dip the tip of that into the water. So as a chemist, we would say the paper napkin is the media or the solid substrate, the marker is the analyte, and the water is the solvent. So I have a little bit of water in this glass, and I've prepared some samples. The one on the right is an orange marker from the markers I showed you, and the one on the left is a yellow marker covered over by a blue marker, and you can see it's green. And if you remember your color wheels, yellow and blue makes green. So what we're going to do is dip them into the water, and then we're going to watch as this develops. So what's going to happen is the water is going to be absorbed up through the paper napkin, and as it gets higher, it's going to begin to pull the colors, which are water soluble, with them. Now the one on the right, which was orange, you can start to see yellow is beginning to climb, and the orange kind of reddish is staying behind a bit. With the yellow and the blue that I put together, again, the yellow is climbing. You might even be able to see a little bit of greenish tinge in the middle, because a little bit of blue is moving, but not much. And we're just going to watch these as they develop. These are two mixtures of different colored inks, one that was in the marker and one that I just created by myself. Now it's a little hard to see the water line here, but the water's going to move up faster than the actual colors are going to move. So when the water gets near the top, that's pretty much going to be the end of it, and it's no longer drawing the colors up with it. But you can see very quickly the orange marker that we used on the right hand side is separating into red and yellow, and that makes sense because red and yellow makes orange. And on the left hand side, I actually made the mixture by using a yellow marker and a blue marker. So this is a very fundamental, but I think kind of fun way to look at chromatography. There are a couple of things you can play with here. You can use a paper towel and a paper napkin and a coffee filter and see if it changes the amount of separation that you get, or the speed at which things get separated. Water is the only solvent that we're going to use because it's the only really safe solvent that you have at home. But realize that when you get to middle school and high school and you go into a science lab, you'll get to use other solvents that are a little less safe and less likely to have at home, but the solvent changes how things separate, the media changes how things separate, and the nature of the mixture itself. So have a little fun. Try the coffee filter, the napkin, and the paper towel. Let's just use water and try different things around your house and see what are mixtures and what are not mixtures. You want to stick with colorful things so that you can see it visually, though. Other than that, have fun with it. You can see, just to kind of go back to these, the yellow on the left-hand side is moving faster than the yellow on the right-hand side, which probably indicates that it's a different yellow ink that was in the orange marker versus the yellow marker and the blue marker that I mixed together. So I hope this has been interesting and instructive, and maybe we'll come back and do some other summer science. Love the alliteration, gotta do it. But you guys have fun with this. Make sure you talk to mom and dad before you get busy with this so that you have a place you can do this without making a mess at home. Thanks, guys. See you soon.